Good evening, everyone. Class 12th, topic name Rearrangement of carbocations during formation of haloalkane. In previous video, we have done one preparation method of haloalkane with the help of alcohol and HX, ROH, alcohol, HX, halogen acid. We can create RX and H2O, haloalkane. This was the preparation method that we have done in last video. Now, in last video, we have also done this whole process will happen through an intermediate carbocation. So this topic is related to that carbocation. What will happen to that carbocation? Let's check with one proper example. Suppose we have this alcohol and I am going to react it with HX. You can use any HX like HCl, HBr, HI, HF, whatsoever you want to use. So, how this reaction happens? Bond between H and X will break. The electrons will shift toward X due to higher electronegativity of X, and H will generate as a electrophile, X negative. Now this electrophile needs electron, and who can provide electrons to it? Oxygen, carrying a lone pair, and also due to very high electronegativity, it is carrying a negative charge. So H will go toward it. Now between this H and O, dative bond will generate. And we also know if oxygen is making third bond, the dative bond, so it will carry a +1 charge. Now in this condition, the oxygen is highly unstable. So what it will do? It will break bond from carbon, and both electrons will go toward oxygen because oxygen is more electronegative than carbon. So it have a more power to attract electrons. So because this carbon is losing its electron, so will carry a +1 charge with a vacant orbital, and this H2O will release out as a stable product. Now this is the intermediate carbocation. What is the degree of this carbocation? Carbon carrying a positive charge is directly connected to a one carbon, single carbon. You can watch. So degree of this carbocation is 1 degree carbocation. Now what will happen next? This is positively charged carbon. This is X negative is going to attack on this carbocation and the product will generate. But wait. What is new here? This carbocation, 1 degree carbocation, will change itself to better carbocation. How? Like this. Out of any these three carbons, like suppose this is CH3, methyl group it is. So methyl group will shift itself to here. Between carbon-carbon bond will break and both electrons will go with this carbon, this methyl group, and those pair of electrons will make coordinate bond with this carbon, due to which a new intermediate will generate. The positive charge of this carbon will finish because one electron, this electron is going to make bond over here. One electron will remain with this carbon, and this is the extra electron which is carrying, which this carbon is carrying, will deliver to this carbon. So this carbon and this carbon both will become neutral. Problem will be for this carbon who have lost its electron. This electron was of this carbon. Now due to loss of this electron, this carbon will carry a vacant orbital and a +1 charge. Now this is also carbocation, but degree is changed. This carbon which is carrying a positive charge is directly connected to 1, 2, 3 carbons. So degree is 3 degree carbocation. In 11th class, we have understood 3 degree carbocations are more stable than 1 degree carbocations. That's why 1 degree carbocation is changing itself to 3 degree carbocation, because every reaction wants stability. So whenever it is getting a chance to become stable, it will use it. Here 1 degree carbocation have a chance to become better carbocation. That's why it is showing rearrangement. Methyl shift. Methyl molecule is getting shifted, due to which 3 degree carbocation is generated. Now what will happen, that we already know. This is X negative will attack here, and the final product will be this. Please satisfy all the valencies by hydrogen. Hydrogens I am not writing, but hydrogens are always there. So this will be the major product. What was our expectation? Expectation was this: 1 degree carbocation will generate and X negative will attack. So the expected product was this one. X, we were thinking it will attack on this carbon. But due to rearrangement of 1 degree carbocation to a better carbocation, X is going to attack on this carbon, major product. This is unexpected product, and this was expected product. So here expected product will be minor, means very few amount of particles are going to perform this reaction through 1 degree carbocation. But a major amount of particles will convert themselves to 3 degree carbocation, and major amount of product will be this one. So this was the topic in which we have a rearrangement of carbocations during the formation of haloalkane. So whenever carbocation is able to convert themselves into a better carbocation, they will do it, and the major product will be decided by stable carbocation, and minor product will be decided by unstable carbocation. This is the end of the topic. Thank you very much.